Hello everyone, I am Ananya and welcome back to MAM Pathshala. In last video, we learned about the classification of additive manufacturing. Today's video onwards, we'll be focusing on two metal 3D printing or metal additive manufacturing processes. Those are PBF and DED, powdered bed fusion process and directed energy deposition process. So in today's video, we are going to see a very important component of a laser powder bed fusion process, that is LPBF. First of all, we need to know why we are focusing on this LPBF process because of its advantages. First one is micron level accuracy and second one is rapid printing. This LPBF process is having very crucial component, that is laser beam delivery system. This laser beam delivery system is responsible for these two advantages like micron level accuracy and the rapid printing. How? Because of its components. So let's discuss the components of the laser beam delivery system in today's video. So let's start today's video. Let's assume this is the laser source. I am not going into the deep of the laser construction, how the laser is made. Let's assume this is the laser beam coming from the laser source. The first component of the laser beam delivery system is the collimator. So this is the collimator. This is a schematic of the beam delivery system. I'm not drawing the exact component and its geometry. Now the laser beam is coming out of the collimator and it's parallel. So the working of the collimator is to make the laser beam parallel. The next component in this beam delivery system is the galvo scanner. So this is a very crucial and important component of this LPBF system. Because of this galvo scanner, we basically achieve the micron level accuracy and the rapid printing. How? So first of all, this is the powder bed over which the recorder will record the powder layer. The laser will come and consolidate the particles present over the powder bed. So the galvo scanner is making the laser beam move over the substrate or the powder bed very fast, very rapidly, and also it is used to bend the laser beam wherever it is needed. So now the laser beam is bent, and the next component in this delivery system is a lens. It's basically a F-theta lens. So F-theta lens is nothing but an arrangement of multiple lenses. It's basically a plano-convex lens. Why this F-theta lens is used? Why not a normal plano-convex lens? What is the working of F-theta lens? Let's understand. So first is the galvo scanner. It is the galvo scanner. So first of all, galvo scanner is used, as I said, to make the laser beam move over the build platform very rapidly. If this is the top view of the powder bed, and suppose we are making part like this over this powder bed. So the laser beam needs to consolidate the powders present over this powder bed for each layer, right, in powder bed fusion process. The typically used laser spot dia in powder bed fusion is in the range of 100 to 120 micrometer. So it's basically very small. This diameter is this. And this spot dia, this laser beam will move over this substrate in this manner with a very fast speed. So we cannot even distinguish a single spot over the substrate or the powder bed. We'll just see that the strip of laser beam is moving like this. But in actual, the laser beam scanned like this over the powder bed. So the galvo scanner is doing that work. It is making the laser beam move over the build plate, over the powder bed so rapidly that we see a strip of laser beam instead of the single focus spot. So this is one advantages of using Galvo scanner. Now another very popularly used metal additive manufacturing is DED. I have mentioned in my last video, directed energy deposition. In DED, a cladding head is used through which the laser and the powder particles both come simultaneously, deposit over the build plate. Now this is the cladding head, consists of arrangement of lenses and other components. But this cladding head here is attached to a CNC, which is responsible to move this cladding head over this build platform. But the product developed using DED doesn't have that much micron level of accuracy and also the rapid scanning advantage, because this CNC is not capable of moving this cladding head very rapidly over the build platform. Why we are here mentioning CNC is because in other manufacturing processes also, people often use CNC to move this type of tools or cladding heads or this sort of things. But in laser powder bed fusion, Galvo scanner is used instead of CNC. Why? The first point is CNC cannot move the laser beam very rapidly over the build plate, what the Galvo scanner can do. Another thing is, if CNC can move the laser beam, there will be vibration in the machine and the part will be distorted. So the result will be not that much good and the micron level accuracy cannot be achieved. So these are the main reason why CNC is not used in case of laser powder bed fusion. Instead, Galvo scanner is used. So this is the first component of laser beam delivery system. The another component is that F theta lens. Let's understand this one. So as I said, F theta lens is nothing but arrangement of multiple lenses. It's basically a plano-convex lens where one side is plane, another side is convex in shape. So these lenses are used to make the parallel beam focus over a build plate. This is a normal working principle of lenses. So this will be the focus spot. So here is another question, why F theta lens is used? Why not normal lenses are used? So basically in powder bed fusion, this thing will be fixed from which the laser is coming. This is the powder bed which can move in Z direction only. So if the bed size is this much, this laser needs to move from this end to this end. And if we are working at focused position, then this point and this point, and if the laser is coming at this point or this point, all these points should have the focus of the laser beam. We all know if this is a normal lens, the normal working principle of lens says if this is a parallel beam, the lens will focus the parallel beam at its focus position. This is the focus of this particular lens L1. This is F1 and this distance is F1. Okay. Now, if the parallel beam is coming from this direction, the lens will focus the laser or the light over this position. And if the light is coming from this direction, then the lens will focus the laser beams over this point, or this will be the focus. The locus of all focuses are an arc for normal lenses. This is a normal working principle. But in F theta lens, I am drawing the schematic of F theta lens like in this manner because there are multiple series of lenses. So if the laser beam is coming from this direction, it will focus at this point. Suppose this is a F1, this is the focus of this F theta lens, L2. If the laser beam is coming from this direction, the F theta lens will naturally focus it on this position. And if the laser is coming from this direction, this F theta lens will focus it on this point. and the locus of all the focuses are a straight line or a plane. This is the main advantage of using f theta lens. Now let's think about it. If this is my substrate is always a plane, right? And over this substrate, if we are making part from this point to this point, this end to this end, if we are using a normal lens, it will not be capable of pointing the laser beam everywhere with its focus position. And we all know the main and the important thing about the laser metal deposition is its energy density. How much energy or how much power we are getting per unit area. This is the focus spot, so pi d square by 4 its area. So the power density is this thing. So the power density is power by unit area. And this is the main thing in this laser metal deposition, and we need to ensure that on every position over the build plate, this power density should be constant. But here, if this is the focus point and when the laser beam is falling at this position, this is the defocus region or this is not the focus spot. So the laser spot dia will increase. As a result, the power density will decrease. So we cannot get a constant power density over the build plate, over the whole powder bed. This is obviously a disadvantage of using a normal lens. But if we are using f theta lens, if this is a substrate, this f theta lens can ensure that wherever the laser beam is falling over this powder bed, it will have its focus position only. So the laser power density or the energy density will be constant for the whole build plate or the powder bed. So this is the advantage of using f theta lens. Also another thing, as I said, this is a normal plano-convex lens. Then why we are calling it as f theta lens and not a plano-convex lens? First of all, the laser beam is coming through the galvo scanner. So now let's assume this is the galvo scanner. The laser beam is coming. This is the collimator, the first component from which the laser beam is coming, falling over the galvo scanner. This is a galvo scanner. Now the laser beam has bent. So let's simplify the drawing. If this is a laser beam, this is a scanner. The laser beam is falling over this lens. It will be focused upon this point over the powder bed. Now, if the scanner has moved at this position and now the laser beam direction has been changed and now the focus spot is at this direction. So this is basically the theta, and this thing will be f into theta. F is the focus and this theta is how much angle the scanner has moved. Now the scanner needs to move at different position, different angle to focus the laser beam over the whole powder bed. So this is the angle, how much it has moved, theta. And if the focus spot of this f theta lens is f, so this distance will be f theta, and for a particular theta up to f theta position, the galvo scanner and the laser f theta lens both are capable of making the laser beam move over the build platform and also make it focused. So this is why this sort of lenses are called f theta lens. So these are the two most important components of laser beam delivery system. One is the collimator to make the laser beam parallel. Second is the galvo scanner to bend the laser beam and also to move the laser beam over the build platform very rapidly. And third one is the f theta lens to make the laser beam focused all over the powder bed. So these are three most important components of laser beam delivery system in LPBF process, which are very much important in terms of the accuracy or the product quality we are getting from our additively manufactured parts. So this is all about today's video. If you have any doubt about these 3 components, or you want to know more about these components, or you want to add something to this video, please comment down below. Let's meet in my next video. Till then, happy printing!